Welcome to Medical Learning Hub. This is another day, another session of mathematics. Here we have a question that you're supposed to prove by induction that 1 cubic plus 2 cubic plus dot 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 plus n cubic is equal to 1 over 4 n squared into bracket n plus 1 squared. Okay, proof by induction is all about proving the statement, the validity of the statement. That if the statement is valid for n equals 1, then for it to be true, we expect to be also valid for n equals k, then for n equals k plus 1. If all that is satisfied, then we can prove that the statement is valid for all values of n. So let's go to task. Here's the solution. First one, let's start with n equals 1. Take your left-hand side, and here is the right-hand side. For the left-hand side, you take the last term, which is n cubic. And for the right-hand side, you take the whole of the right-hand side, that is 1 over 4, n squared, n plus 1, this one squared. So if n equals 1, here we shall have 1 cubic. Here we shall have 1 over 4, 1 squared into bracket, n is 1, then we add 1 there, we square. 1 raised to any power gives us 1. Then here we have 1 over 4 times 1 times 1 plus 1 is 2, 2 squared, that is 4. So at the end of it all, we get this one also equal to 1. So the first part of the proof is done. Then the second part, we have to prove for n equals k. What we do now, we replace n for k on both sides of the statement. So there we go. We have 1 cubic, then plus 2 cubic, plus dot dot dot, plus now where there is n cubic, we put k cubic. This equals the right-hand side. The right-hand side is 1 over 4. 1 over 4. Then n, we put k squared into bracket k plus 1, again squared. So remember, we had already proved that n is valid for n equals 1. 1 is constant and k is constant as well. So if it was valid for constant 1, it is also valid for constant k. So we don't need to carry any further calculation from here. So after this step, then what is the next one now? The next one is for n equals k plus 1. For n equals k plus 1. Okay, so what do we do with k plus 1? We add a new term on the left-hand side, including k plus 1. Once you add on the left-hand side, in order not to distort the meaning of the statement, you have to add the same on the right-hand side. So here we go. For n equals k plus 1, our new statement now becomes, we shall have 1 cubic, then plus 2 cubic, then plus, remember we ended at k, then plus k cubic, then plus, this will be now k plus 1, we say cubic, then we shall add the same term on the right-hand side. So on the right-hand side, we will have 1 over 4, then there is k squared, okay, then there is, oh sorry, there's multiplication here, I don't know what happened, k squared, then k plus 1, yes, k plus 1 squared, then k plus 1 cubic, k plus 1 cubic. So as you can see from this statement that we have added this new term on the left-hand side, and we have done the same on the right-hand side. So on the left-hand side, there are no much simplification which you can do. Okay, let's leave it at that level. So let's deal with the right-hand side. So this equals Look at this statement here. We have k plus 1, then squared, then there's k plus 1 cubic. What does it mean? That when you take out k plus 1 squared. So this is the common factor now. It is 1 over 4 into bracket k plus 1 squared. If you do that, here we shall remain with k squared, then plus, remember we're taking outside 1 over 4, so this new term will be 4 times k plus 1. Okay, it should be like this, which equals 1 over 4. This is k plus 1 squared into bracket, this is k squared, this is 4k, then plus 4. Okay, looking at this one, I'm seeing a perfect square of k plus 2. K plus 2. So here we shall get 1 over 4, then k plus 1 squared. Then this one is k plus 2, again squared. Okay, k plus 2, again squared. So this is our new statement. This is our new statement. And what we have on the left-hand side, let's combine now a full statement. So we have 1 over 3 plus 2 power 3 plus k raised to power 3 plus k plus 1 raised to power 3 to be equal to the right-hand side, which is 1 over 4, then k plus 1 squared, and k plus 2 squared, like that. Can we simplify it any further? No need to do that. No need to do that. So what can we do now? Let's do the checking now. Let's do the checking. Let's try to check what if k, now we take our k to be equal to 1, with the left hand side be equal to the right hand side. What do? We take the last two terms of the left hand side. So left hand side, we take k cubic plus, this is k plus 1 cubic, and on the right hand side we take the whole of it. Okay, this is right hand side, 1 over 4, then this is k plus 1 squared, then k plus 2 squared. Taking k equals 1, the left hand side becomes 1 cubic, then plus, this is 1 plus 1, again cubic. The right hand side becomes 1 plus 1 squared, then 1 plus 2 squared. Here we have 1, then plus 1 plus 1 is 2, 2 cubic. This is 8 equals, here we have 1 over 4, then 2 squared, that is 4. Here we have 3 squared, that is 9. Okay, so the left hand side we are getting 9, and the right hand side we are also getting 9. So what does it mean? It means that our statement is valid for n equals k plus 1. So if the statement is true for n equals 1, n equals k, and n equals k plus 1, then it must be true for all values of n, hence proved. Okay, thank you for watching. Expect to see you in the next video.